All right, so our next topic is going to be 6.5. We're going to be talking about solving radical equations. So let's take a look at a couple of steps. All right, and the first one that I have listed here is kind of sort of optional. I can do this without converting, but the way we have the steps worded, it's easiest just to convert. So step number one, I want to convert the radical into a rational exponent. So remember, if I have the nth root of x to the m power, right, I want to rewrite this as x to the m divided by n power, right? These are equivalent. I could do the rest of it if I left it in radical form, but some of the wording is going to change. Okay, so the first thing I need to do once I've made that conversion is I need to isolate the radical part of the equation, right? That has to be by itself, right, before I can raise anything to a power, or then I have to actually distribute and FOIL and do some other things that it's not going to work the way you want it to. Once you have isolated that radical, I want to raise both sides of the equation to the reciprocal power. For instance, when I raise both sides to a reciprocal power, so the n over m power, these two powers will cancel one another out, and thus I'm left with just that quantity inside, which is what I want, right? Which is going to then, in turn, clear the radical. All right, once I've cleared the radical, now I want to solve using whatever method is appropriate. And I say that because we might have a linear function, we may have a quadratic function, or it is possible that we have another radical and I have to go through this first couple of steps over again. Last but not least, we always, with these problems, want to check for extraneous solutions. Okay, again, an extraneous solution is one that we find through all valid and correct steps and methods that doesn't actually work in the original equation or problem. All right, the main reason why we get them here, one, if we have an even index root, I can't have a square root of a negative when I'm dealing with real numbers. And two, when I'm raising both sides of the equation to a power, I'm effectively increasing the degree. So first degree equation has one solution. Second degree equation or quadratic has two solutions, so on and so forth. All right, we're dealing with something that's not technically a polynomial here, so it doesn't 100% follow that rule, but kind of sort of loosely does. Okay, when I raise the power on both sides, not always, but sometimes I actually introduce a solution that wasn't there before. Okay, so that's why I have to go back and make sure that all the solutions I find actually work in the original equation. So let's do one here, right? This is somewhat of a warm-up problem. This one actually showed up in your version of the notes prior to the steps. So if I want to solve this, right, again, I want to isolate my radical, right? I want to get this square root of 2x minus 4 by itself. So I'm going to do this without actually switching to the rational exponent. So I'm going to subtract 2 on both sides. All right, it's going to leave me with square root 2x minus 4 equal to 4. Now I want to get rid of that square root. I'm going to get rid of that square root by squaring both sides of my equation. Right here, they're going to cancel on the left, leaving me with 2x minus 4 equals 4 squared is 16. Now I add 4 to both sides. I get 2x equals 20. I want to divide by 2. I get x equals 10. Again, I want to check that in my original equation up here. So if I plug that 10 back in for x, right, I'm going to have 2 times 10, or 20. 20 minus 4 is 16. The square root of 16 is 4, and 2 plus 4 is in fact 6. This does check out. We got a good solution. Okay. Now, if I come down here, and let me actually take this work, and I'm going to copy it real quick. I'm going to paste it right here. All right. So here's my work from that original equation. All right. So if I had decided that I was going to take and rewrite the radical as a rational exponent, remember that the square root of x would be x to the 1/2 power. So here, my quantity 2x minus 4 under the square root is the same thing as quantity 2x minus 4 to the 1/2 power. So now let's go through and solve it. All right, I'm going to subtract the 2. It's going to equal 4. I want to raise both sides to the reciprocal power. Well, what's the reciprocal of 1/2? Isn't it 2? So if I raise both sides of my equation to the second power, these cancel, okay? Leaving me simply with that 2x minus 4 equals 16. And you'll see that from here, my steps are exactly the same, okay? Fundamentally, raising both sides to the reciprocal power is the same thing as in this instance having a square root and squaring both sides. They do the same exact thing, just a different way of writing it, tomato, tomato, okay? So let's try another one, all right? So here I have 2 times the quantity x minus 2 raised to the 2/3 power plus 4 equals 22. So again, the very first thing I need to do is I need to isolate my radical here, right? So I need to get this all by itself, right? So to do that, right, we're going to subtract 4 on both sides. It's going to give me 2 times x minus 2 to the 2/3 power equals 18. And when I divide by 2, I'm going to get x minus 2 to the 2/3 power equals 9. Now I want to raise both sides to a reciprocal power, right? So the reciprocal of 2/3 is going to be 3/2. So I want to raise both sides to the 3/2 power, right? On the left, they're going to cancel one another out, leaving me simply with the x minus 2. On the right, I have 9 to the 3/2 power. Okay, remember, I want to make things smaller before I make things bigger. So really what I'm going to do is attempt to simplify 9 to the 1/2 and then cube that result. So the square root of 9 is going to be 3. 3 cubed is 27. Okay. And then I want to also then add a 2 to both sides, right, which is going to give me a 29. Now, there's one thing, and if you go back, remember when we had x squared equals 4. And if I take a square root of both sides, remember that when I took a square root of both sides, I needed a plus or a minus, and here I got a plus or a minus 2. Notice that part of what we have here, okay, if I look at that x minus 2 to the 2/3, if I rewrite this like that, don't I right here have a quantity that's squared? And effectively, when I take, when I raise both sides of my equation to the reciprocal power, and that denominator is even, I'm effectively taking the square root of both sides. So what I actually need is a plus or a minus. Okay, I must put that plus or minus in, because the squared part here, right, or here, guarantees the positivity. So the quantity in there could have been positive or it could have been negative. So what I really need to do here is I need to actually solve 2 cases. So let's get ourselves a little bit of room. So I actually have x minus 2 equals 27, which does solve and give me the x equals 27, or 29 rather. But I also have x minus 2 equals negative 27, and when I solve it, I get x equals negative 25. Okay, so I do have to put that plus or minus in here, and I do have to solve both of those individually. Now I want to go back to my original equation and check both solutions. So let's do our x equals 29 first. 29 minus 2 is 27. 27 to the 2/3 power. Right, cube root of 27 is 3. 3 squared is 9. 9 times 2 is 18, plus 4 is 22. This checks out. So let's deal with the x equals negative 25. Negative 25 minus 2 is negative 27. The cube root of negative 27 is negative 3. Negative 3 squared is positive 9. Times 2 is 18. And plus 4 is 22. Both these answers check. We're good to go. All right? So, and just to recap there, again, if whenever you raise both sides to a reciprocal power, if the denominator of that power is even, whether it's a 2, a 4, a 6, whatever, I've taken an even indexed root of both sides and I need a plus or minus. All right, let's try the next one. All right, so I've got the square root of x plus 7 minus 5 equals x. All right, I'm going to leave it as a square root for right now. Okay, so I have x plus 7 inside my square root equals, and if I add that 5, I want to isolate, I get x plus 5. All right, again, I'm trying to get this square root by itself so I can square both sides. So now, if I go through and I square both sides, don't forget you're squaring the entire side. I need parentheses here. On the left, the square and the square root cancel one another out, and I'm left with just x plus 7. On the right, I have x plus 5 quantity squared. And when I FOIL that, I get x squared plus 10x plus 25. So I've now cleared my radical. I need to ask myself, what's the appropriate method through which I can solve the remaining equation? And again, here, I've got a quadratic equation. So I need to attempt to factor and solve. If it doesn't end up factoring, then I can go to quadratic formula, completing the square, or one of my other methods. So let's get it set equal to 0. All right, so I'm going to subtract over the x. I'm going to subtract over the 7, and I'm going to get x plus 9x plus 18. Or excuse me, x squared plus 9x plus 18. So I need two numbers that multiply together to give me 18 and add to 9. Okay, those numbers are going to be 3 and 6. Right, which are going to give me two solutions of x equals -3 and x equals -6. So let's go back to my original equation here, and let's do a little simplification. Let's try these and see if they actually work. So if I substitute x equals -3 into my original equation, I have inside the square root, I have -3 plus 7, right, which is going to be 4. Square root of 4 is 2. 2 minus 5 is -3, and this one does check out. Okay. For my next example, right, we're going to have, or my next solution, we're going to have -6 plus 7, excuse me, -6 plus 7, which is going to be 1. Square root of 1 is 1. 1 minus 5 is -4. -4 does not equal -6. So we found an extraneous solution. So what I want you to do when you find that extraneous solution, I want you to put an x through the equal sign, and I want you to write an ext underneath of that solution so that I know that you found it to be extraneous. Okay? I still want to see it because you should have found that solution when you solved everything. So don't erase it, right? All right, leave it there, but I want you to put an x through the equal sign, and I want you to write ext underneath. And again, notice when I talked about the degree of the function, my highest exponent here was an x to the first, right? I had a function that was 1 to 1 here, okay? Then as soon as I squared both sides, now I introduce and I end up with an x squared. I went from something where I should likely be expecting one solution, and now I've got two. Let me also give you a real quick sketch here of what this potentially could look like. Okay, so let me use two different colors. So I've got a square root function, okay, that looks something about like this. And then I've got a linear function. So what I could have is a linear function, all right, that doesn't touch at all, and we get no solution. I have a linear function that literally touches. Imagine that touching at just one point here, and I get one solution. I could have a linear function that touches in two places and is intersecting my square root in two places where I get two solutions that work. Or I could also be down here somewhere and have a linear function that misses on the left side but touches on the right and has exactly one solution. All right, because what I really have, if I came back to this, when I had square root of x plus 7 equals x plus 5, I have a square root function on one side and a linear function on the other. Okay, so there are a lot of different cases that could be taking place here, and this is why we have to go back and check for those potentially extraneous solutions. All right. Got an application problem here, all right? So it says the maximum flow of water in a circular pipe is modeled by the following formula: Q equals AV, where A is the cross-sectional area of a circular pipe, and V is the velocity of water, Q is the max volume of water that can flow through the pipe. I want to find the diameter of a pipe that allows maximum flow of 50 cubic feet per minute at a rate, or at a velocity rather, of 600 feet per minute. Okay. So first things first, all right, and I already drew a sketch up here of a pipe and then the water flowing through. All right, let me zoom in here for a second. All right, so what I'm looking for at the moment is the cross-sectional area of that circular pipe. I want to know what is the area here. Okay, so the area, this is a circular section, so area equals pi r squared. Okay, so if I make a substitution in here for the A in my Q equals AV formula, okay, we're going to end up with a formula that looks something like Q equals pi r squared times V. Okay, so what I can do, right, when I look down here at the bottom, I want to find the diameter, right, and I'm going to highlight that because that's kind of important for me here in a little bit, right. I want to find the diameter of a pipe that allows a maximum flow of 50 feet per second, right? So this is going to be V equals 50, or 50 feet, pardon me, 50 cubic feet per minute, right? And that's actually going to be Q, not V. Okay, at a rate or a velocity of 600 feet per minute. That's my V. Okay, so what I'm going to end up doing here when I solve this, right, is I'm going to solve for R. So I'm going to find the radius, right? Once I find the radius, then I'm going to have to use that to find my diameter. So if I substitute in here, I'm going to have 50 equals pi r squared times 600. Now I want to do this and keep it as exact as possible. So I'm going to end up with r squared equals, and if I have all multiplication here on the right, if I divide both sides by 600 pi, I end up with 50 divided by 600 pi, okay, equals r squared. All right, yes, I know I can reduce that, but for right now, I'm going to leave it like that, and I'm going to take a square root of both sides. The decimal here is what's really going to be important to me. So here I'm going to have square root of 50 divided by 600 pi. All right, so let me pull up my graphing calculator. All right, and let's put this in. All right, so I'm going to have the square root of 50 divided by. Now notice I have more than one quantity here in my denominator. All right, if I just write 600 pi, okay, this is going to interpret that the way I have it entered right now in the graphing calculator as square root of 50 divided by 600 and then times pi. That is not what I want. I want that pi in my denominator. So it's going to be important that here we use parentheses around that entire denominator. So let me go back in the graphing calculator. Okay, I want to make sure that we insert some parentheses here. So I want 600 pi in parentheses, and I want to close those parentheses. Okay, so here I'm going to get a radius of 0.1628. Okay. Right. This is in feet also. Okay, I was looking at the decimal and was trying to figure out why it didn't really make a whole lot of sense and why I asked to round to the nearest inch. Okay, this is in feet, not in inches. Okay, so we're gonna have another unit conversion that we're gonna have to do here at the end. All right, so the next thing, this is my radius. To get my diameter, I need to multiply by 2, right? Because diameter equals 2 times the radius. So diameter here is going to be 2 times 0.1628. Right, and we're going to get a diameter of 0.3256. All right, and again, this is in feet. Right, if I want to convert feet to inches, there are 12 inches per foot. Right, so I need to multiply by 12 inches in 1 foot. So when I make my conversion here, all right, if I multiply by 12, we're going to get 3.9072 inches, or a 4-inch pipe. Okay. So there's a lot going on there. We can talk more about this when we get into class. We are going to see a couple of word problems, but again, the hardest part in some of these is going to be identifying everything you need, setting everything up, and also pay attention. I almost made a mistake there by identifying the wrong value for the wrong variable. Okay, I almost wrote v equals 50. Well, I did write v equals 50, and I caught it, and I almost made the substitution with the incorrect value. Okay, so let's come down here to this last problem. What if I can't isolate a radical? Right here I've got square root of x minus 3 times square root of x plus 4 minus 1. I've got two different radicals, so I can't isolate one of them. I can only isolate one at a time. So let's do that. Let's isolate one at a time. Right now I've got the square root of x minus 3 isolated. Let's actually square both sides here. Okay. If I square both sides, right, on the right or on the left, it's simply going to cancel. I have x minus 3. But on the right here, right, this is going to be square root of x plus 4 plus, minus 1 times square root of x plus 4 minus 1. And again, I need to FOIL for this equation. So what we're going to get, we're going to have square root of x plus 4 times square root of x plus 4 minus 1 times square root of x plus 4 minus 1 times square root of x plus 4 and plus 1. So here, the first term, I have essentially square root of x plus 4 squared, or simply x plus 4, minus 2 times square root of x plus 4 and plus the 1. So when I combine like terms here, I end up with x plus 5 minus 2 square roots of x plus 4. Okay? When you have something like this, you have to show that work. You have to multiply it out. So again, now what I want to do, all right, I want to isolate that new radical. So I'm going to subtract an x on both sides, and I'm going to subtract a 5. Well, x minus x is going to be 0x, and we're going to end up with a negative 8 equals negative 2 times square root of x plus 4. I'm going to divide both sides by negative 2, and I get 4 equals square root of x plus 4. Now I've re-isolated the new radical. I want to square both sides. When I square both sides then, all right, I'm going to end up with 16 equals x plus 4, or x equals 12. Now, here I think it would be really, really smart if we went back and actually checked our solutions. Okay, so actually I don't even need the graphing calculator for this one. If I check both sides here, when I plug into the left, I have square root of 12 minus 3. 12 minus 3 is 9. Square root of 9 is going to give me 3. On the right, I have square root of 12 plus 4, then minus 1. 12 plus 4 is 16. Square root of 16 is 4. 4 minus 1 is, in fact, 3. I get 3 on both sides. This does check out. This solution is good to go. All right, so if you have more than one radical, okay, we can still solve this, all right, but we're going to have to isolate the radical and raise the appropriate power more than once. And I have to isolate one radical at a time. It's probably going to be messy, okay? Make sure, be meticulous, show all your steps, show all your work as you combine like terms, all right? Have a good night. Take a look at maybe some of the problems, or try one or two of the other slides that are in the notes that I did not use in the video. And we'll see you guys tomorrow in class.